Hello, I'm Krista Campbell. Thank you for joining us today for analyzing big water data sets for informed decision making. Today's webinar is the second in a three-part series. If you missed the first webinar, Understanding Non-Revenue Water Loss with Powerful Analytics, it was recorded and posted online. The next webinar, The Power of ArcGIS and Predictive Analysis in Water Utilities, is scheduled for October 16th. You can view the first webinar and register for the third webinar at go.esri.com. Put your data to work. Today, we will focus on big data sets. My colleague, Derek Lorbecki, is going to discuss and demonstrate how Esri analytical tools allow you to view trends in near real time, discovering patterns and providing information essential to more effectively manage your system. I hope you enjoy the webinar. Derek?
Thanks, Krista. So, like Krista said, today we're going to be focusing on, large to big data sets and how we can use things like geoanalytics and insights to really dig through that data and make it usable and available to people inside of your organizations. So what will we actually be using during this webinar? So we'll be using insights for ArcGIS to really explore and dig down into our data to answer questions and look at patterns and trends. We'll be using Geo Analytics Server and the Spatial Temporal Big Data Store to process these large data sets very quickly to get that information out to people via things like insights, but also maps and applications. So the goal of this webinar is to show that we can actually take some of these data sets that may be too large to use effectively in desktop or web GIS and use these strategies and these tools to break them down and look at them in a way that makes a lot of sense for an organization and for a person in a line of business. So what are we going to be looking at? So we have 4 data sets we're going to be focusing on. The first is water quality information that has about 500,000 records going back to the late 1990s. We're going to be looking at permit information from South Florida, which has upwards of 200 to 300,000 records. Then we're going to be digging into a truly big data set, and this is rainfall data from Southwest Florida that has, in this case, 104 million records. And then we're also going to be looking at some consumption data as well that is fairly large, 1.3 million records going back a number of years. So we're really focusing on large data sets and the things we can do inside of insights and geoanalytics to start looking at these data sets. So why are we going to use insights? What makes it special that causes it to be able to look at these large data sets very quickly and effectively? Well, it's because of the way that insights functions. We can process through these large pieces of data much more quickly than we could by using normal desktop GIS. A lot of times these large data sets have complex relationships. For example, 1 million consumption records back to 30 or 40,000 water accounts. Insights allows us to create these complex relationships, but also effectively look at our data through these relationships. A lot of the times the data that we're going to be looking at may have many attributes. In the example of the water quality data, we have dozens and dozens of different types of sample results that we need to be able to filter and sort through very quickly. And Insights is going to allow us to do that. And lastly, in some instances, our data is unique. We may want to look at an individual station or an individual account user while still not losing the overall view of all of the data that we're looking at. So these are the reasons why we're going to use insights kind of for the analysis portion of looking at these large data sets. Now, Geo Analytics Server comes into play when we're actually looking to process some of this data. So the big thing that Geo Analytics Server does is allows us to greatly increase the speed at which we perform things like density analysis and spatial aggregations. Data sets that may take hours or days to process on typical desktop GIS can be processed in a matter of minutes to just hours using Geo Analytics Server. This allows us to take these large data sets and do extremely complex aggregations and things like density analysis on them very quickly. And the best part about Geo Analytics Server is because everything is being accessed through our portal. Once we create those data sets, they can become immediately available for people to use in things like insights, but also applications and web maps. So we're going to use those tools to really help us dig through this. But before we start, I want to kind of show where these items fit into Enterprise ArcGIS. So if we take a look at this diagram I have here, The three pieces that are in this orange or yellow color, the relational data store, the ArcGIS server, and your portal for ArcGIS make up what's called your base deployment of ArcGIS server, ArcGIS Enterprise. This is really the core of your enterprise GIS deployment. Once you have this in place, it's very easy to add the rest of these pieces. Geo Analytics Server and the Spatial Temporal Big Data Store consist of what I would call our Geo Analytics stack that allows us to process through these large and big data sets very quickly. These can be added on as additional server roles and additional data stores onto our enterprise GIS deployment. Once those are added on, we can then access the information that's processed through those products in things like Insights for ArcGIS, which is simply a web application that sits on top of our enterprise, Portal or ArcGIS Pro, which is our desktop product for accessing Portal, and lastly through Web App Builder for ArcGIS. So by having this base deployment and extending it with things like Geo Analytics Server and Insights, we can really bring this analysis and this large data work more easily to the people inside of our organization. So let's hop right into it and start actually looking at some of this data. So the first place I want to start is using Insights to explore water quality data. A lot of times when I see people using water quality data, they have pre-established dashboards or workbooks or sheets set up so that they can very quickly look through information. We want to recreate this exact type of workflow inside of Insights to give us a very powerful ability to analyze our water quality data. What we have here is actually two data sets. The first is our water quality sites, and you can see that I have that filtered so that we're looking at just water quality sites that are related to our water or wastewater treatment plants. And at the same time, we also have our water quality data itself. And this data consists of about 18 years of records going back to 1999 and has about 500,000 records in it. So the first thing that we want to do is we want to join this information together. We want to take our water quality data and join that to the water quality sites of interest. We're going to do this through the sampling point name. Once this data set is related, we can now start making products with it. The first thing I want to do is create a map with this data set. And I want to look at these based not on their location, but on the actual sampling point themselves. I'm going to make this a little bit bigger so that they're easier to see. And I'm going to change the background of this card to my dark gray canvas. So here are the sampling points that we're really interested in for this analysis. The next thing I want to do is be able to very quickly and easily see the results of these water quality samples at these individual sampling points. So I'm going to do something where I'm selecting my sampling points, the year that the water quality samples were collected in, and the actual results of that sample. And I'm going to create a table from this. Now, at its surface right now, what we're looking at is a table that contains the name, the sampling point name, the year it was sampled, and in this instance, the average result of everything sampled at that location. So at this point, this table isn't very valuable, but I can make it extremely valuable by adding one additional thing to this page. And that's going to be the name of the sample that we're actually looking at. So if I create a table that shows me the name of the sample that was taken, and I connect these two tables together using cross-filtering, now when I select anything in my sample table, we'll see that my list of sampling points and years is automatically updated with the results of that individual sample. So essentially, I've created a pick list of my samples that's going to start updating everything else on my card to give me a real-time or to give me a look at exactly what results for each individual station those samples came up with every year. So now that I have that pick list set up, I'm going to set up a time series graph that allows me to actually look at my sample date and the value that was collected at that sample date. Now I'm going to do this by year. And I can now even break this down further by adding my sampling point. So now when I select something, say for example, E. coli, I can not only see the results for individual years, but I can see the trend overall for each one of my samples that I'm selecting for all of my different sampling stations. The last thing that I want to do is create a box plot of these so I can see various items about the samples, like their high and low outliers and the quantiles of the various samples for each of my sampling stations. So this will take just a moment to draw. So now when I connect these, I have a fully functional dashboard that allows me to select something, for example, like my pH, see the average pH levels per year in a textual fashion for each of my sampling stations, see the trend line for each of those over the course of the years, and see a box plot of each of those. So we can see, for example, here that this sampling station number 5, which is this orange one here that matches the box plot color, has a low number of 6.4, upper whisker of 8.4, and a median of 7.5 for pH. And as I click through my different variables in my water quality samples, we'll see that all this information is updated automatically as soon as I do it. And I can go even one step further than this. If I want to focus on an individual sampling station, all I have to do is filter this data to look at just that sampling station. And now I can do individual analysis on just the single sampling station to see how a particular pollutant has changed over time in that station. So in just a few minutes, I've taken 15 to 20 years of water quality data and created a insights page that I can use to answer really any question about the trend of water quality at any station in my district. We can use lots of other strategies in insights to expose this data. For example, I can look specifically at an individual system, and while a lot of the things we see here are the same, one thing that's a little bit different is that I have information broken down by month in this instance. So we can see the year-by-year concentration, but we can also see the month-by-month average concentration of E. coli in this instance. So it makes sense that most of the time this peaks in July. That's when most of the rain occurs, and it's also the warmest. But we can see that in this station Upper Platte 48, they also have a small peak that occurs in May. So I may want to look at that station and see what could actually be causing that to occur. At the same time that I'm looking at an entire system, I can look at something very specific like total organic compounds inside of my watersheds. So here I have a page broken down where I'm looking at these individual watersheds, and I know for a fact that my requirement for removal of this compound is over 4 milligrams per liter. So anytime I see one of these bars go above that 4 milligrams per liter mark, I can see that I may need to take care of that location. And we can actually see here that this Upper Platte was over that line, but has since been moved down below that line. And lastly, I've set up a chart here where I can look at my entire water, or all of my water quality stations. This allows me to select any individual station that I have and see the sample results for a subset that I'm interested in, but also all of the sample results over the entire course of the history of selecting or collecting information from this water quality station. So by using insights for ArcGIS, I can really create a lot of very valuable pages that I can use to keep my organization and myself up to date on the current status of water quality inside of my district. So we've looked at water quality. The next thing I kind of want to look at is rainfall, since that does have a relation to the quality of water in any given area. So the next thing that we're going to look at is that rainfall. And we actually have two different types of rainfall analysis that we're interested in looking at. The first is going to be looking at information coming from our rainfall monitoring stations. So these are actually permanent stations that exist out in our district that allow us to, in this instance, sample the rainfall, every 15 minutes. And what I'm going to do here is I'm going to get this kicked off and actually create a time series of these rainfall values. Now, this is going to take a few minutes to draw, or a few seconds to draw. What we're actually looking at here is 634 rainfall rainfall sites for around South Florida, but we're joining that to 2 months of rainfall data. And in this instance, that's about 600 and almost 700,000 records that we're joining to for these 2 months of rainfall data to our rainfall monitoring stations. So this graph is done now, but I'm not interested in the average rainfall at these stations. I'm actually interested in the sum rainfall. Well, that's continuing to refresh and compile all of that data. I'm going to do kind of what I did before and actually create another pick list. This pick list is going to allow me to look at the total values or recorded rainfall for this 2 month time period in these individual areas. And it's going to allow me to choose any one of these given stations and see the graph and time series of rainfall in that area. Now you'll notice that some of these rainfall values are extremely high. Well, this happened to be during a time period where there was a large amount of rain and actually massive flooding in the Tampa area. So now that this is all done and been processed, I can enable my cross-tabbing, and I can click on any one of these stations and immediately see the graph of rainfall for that station over the course of this 2 month period. So very quickly, I've taken almost 1 million records, joined them to 600 rainfall or rainfall monitoring station, and created an interactive graph and chart that allows me to see individual rainfall at those stations over the course of my entire period of interest. I can now take this information and do things such as joining it to demographic data to see the number of people that could have been affected by this rainfall. Or I could take this data and then feed it into my water models as well. Now, this is really great for my rainfall monitoring stations, but I actually have a second set of data that I can access when it comes to rainfall. So if we hop into ArcGIS Pro here, I want to look not at my rainfall monitoring stations, but in this case, at rainfall that comes to me from NexRad. So this data is collected every 15 minutes for my entire area of interest. This actually encompasses 17,600 2-kilometer squares. Each one of these squares has information that's given to it every 15 minutes for a time and a rainfall value. And we can see here, as I click down through these, that we're collecting this data every 15 minutes. So for the 2 months that I'm interested in, there's over 100 million records included in this period. So I would never be able to look at that or process it normally in ArcGIS Desktop. But through Geo Analytics Server, I can actually take this 100 million records and aggregate it into something that makes sense for people to understand. In order to access these tools, once I have Geo Analytics Server installed and federated with my portal deployment, I'll see that I have a brand new toolbox that showed up. And this is called Geo Analytics Tools. Now, we'll notice that some of these tools, like the aggregate data or aggregate points, exist in the standard toolbox. But to process a data set like this, it may take days. Using Geo Analytics Server, I can actually process this entire data set in a little less than an hour. Now, what I want to do here is I actually want to take all of those rainfall points that I showed you before and aggregate them into daily rainfall for my entire district. Now, my rainfall doesn't actually exist as a feature class. It exists inside of my portal as something called a big data file share. All this big data file share is a group of CSV files that contain that information about the location, time, and value of rainfall that's been organized by Geo Analytics Server and by my spatiotemporal big data store into a point feature class that I can understand through Portal and through ArcGIS Pro. So I'm going to select this feature class with those 104 million points as my source. We're going to call this our daily rainfall. We're going to aggregate this into that rainfall grid. We're going to do this for every day, repeating every day, starting at the start time of my data set, which in this case is July 1st of 2015. And in this instance, all I want to do is sum up the value of all of the rainfall points in each of those squares for every day. Now, if I were to run this, it would take a little less than an hour to run through those 104 million records. And what I end up being left with is a one-day aggregation that not only I can see where the rainfall has fallen, but it's completely time aware. So I can step through my data set and see how the rainfall increased and decreased over this period of extended high rainfall. I can stop at any given time and click on any of these squares to understand exactly how much rain has fallen during this daily time period. I can also take this data and do aggregations and summaries on it to understand how much rainfall has fallen in an individual area. Now, I'm also interested not just looking at rainfall in those squares, but looking at how rain has fallen in my individual drainage basins. And in order to do that, I essentially take the exact same process that I did before, only instead of using my squares as my source to aggregate my data into, I'm using this drainage basin subset area. When I do that, the results I get look a lot different. Here we're actually seeing how much rain has fallen in each of those drainage basins per day during this time period. I can select any one of these drainage basins and see my average sum rainfall at those stations for that time period. So I can then take this information and feed it to my hydraulic modelers and feed it into my watershed models to understand where the water is going to flow and what potential flooding could actually occur. So in this instance, we looked at both data coming from rainfall monitoring stations and a very large data set containing 100 million records, and turned them into products that can actually be used by people on a day-to-day basis to understand, in this case, how water is going to flow through their district. So I want to turn from water resource focus now to looking more at something that a water utility can do with Geo Analytics Server and insights. And in this instance, I actually want to take a look at some consumption data. But first I realized that I actually had created a rainfall map that I forgot to show with this as well. So along with those aggregations that we created, since those things are just items inside of Portal for ArcGIS, they can be used to create web maps and applications like anything else. So in this instance, I've taken that rainfall data and I've created a time series graph with it, or a time series map with it, that I can use to look at my daily aggregated rainfall in a web map across my area. This is fully interactive, and I can click on any one of these locations to see the rainfall at that individual point on that individual day. And this is possible because all the outputs of Geo Analytics Server just end up as items inside of your portal. So now let's switch over and look at some of that consumption information coming from the White House Utility District. So what we're looking at here is our district metered areas for the White House Utility District in Northern Tennessee. What I actually want to do is take all of my consumption data going back for 3 years, which in this case is about 1.3 million records. And I want to aggregate that consumption data into my underlying district metered area polygons. So to do that, I can use, once again, Geo Analytics Server. Just like we did before, I'm going to go to my aggregate points. Only this time, instead of selecting that big data file share, I'm just going to select my consumption features that I have right in my map. I want to do this into a monthly basis. So we're going to call this our monthly rainfall or monthly consumption. And I'm going to aggregate that into those underlying DMA zones. I'm going to do this for 1 month at a time, repeating every month, back to the start of my data set, which in this instance is the 1st of January 2015. Now I'm going to do a little bit something different here. I'm not just going to get the sum of the data of the consumption. I also want to get the mean of the consumption in each one of these zones. Now, if I were to run this, it would actually take those 1.3 million records and aggregate them in a little more than a minute. You can see here that I actually ran this last week with the exact same variables, and it took 1 minute and 19 seconds to aggregate those 1.3 million records into my underlying polygons. So now that we actually have that data aggregated, we can take a look at the results. the first thing that we're going to see is that we have our monthly sum consumption. Now, since we had a time field in there, this is a time-enabled data set. So I can click through it and see how my monthly sum consumption changes over time for my districts. I can also do the exact same thing with my mean consumption. Since this data set has both of those pieces of information in it when I use Geo Analytics Server. And once again, since this data is simply just sourced from features inside of my portal for ArcGIS, I can very quickly take that information and turn it into a public or internal facing application. So here we are looking at that monthly mean consumption, and I can watch it change over time and ebb and flow as the months move on. I can pause it at any given point and identify on individual months to see what the mean consumption was inside per account inside of that individual location. At the same time that I'm using this data I just created in Geo Analytics Server in things like Web App Builder, I can also start to pull that data into insights for ArcGIS. So if I open up a new workbook and just type in monthly, we'll see that monthly consumption feature class that I just created inside of Geo Analytics Server. Along with that, I also want to pull in some data from my organization. And that's my consumption. So now we've pulled in these two data sets, I can start to look at them side by side, the aggregation of my consumption data and the individual point data that contains 1.3 million records. To start off with, I want to look at my monthly consumption that I just created. And I want to see how this kind of changes based on my zone. So I'm going to take my sum consumption and the name of my zone, and I'm going to create a column chart with it. And immediately I see something that kind of stands out to me. We have these two zones that have an extremely high average consumption. It seems a little bit off kilter for what I would be used to seeing. So I'm going to look at this another way by taking the consumption and then the actual time that it was recorded into a time series. What we see here is we actually do have two spikes. In that station camp area and in that White House West area, we have two spikes where that consumption shoots up a lot higher than it should be. So in my mind, I'm thinking that maybe these are actually data issues here that we're seeing. So for the time being, I'm actually going to filter this data set out to kind of even out those peaks. So now we're looking at a much more regular looking graph of consumption for each one of these zones going over time. Though I notice that in January's, I tend to have a spike in my consumption, which could be because of an accounting process. That's something that I'll need to follow up on. So now that I've kind of understood how this consumption changes in time at my aggregate level, I want to start breaking down how this actually changes in time at my account level. So in this instance, I'm going to switch from using the data that I just created inside of Geo Analytics down to the raw data source that contains the information for each individual account. And I'm going to start by looking at my consumption based on my connection type by year. So what we see here is that we look at our sum consumption. By far and away, our domestic consumption consumes the most amount of water inside of our district. But if we change this over to our average consumption, we can see that this switches a little bit to where our average domestic consumption is relatively low, but our fire and our flushing consumption at an individual levels consume the most amount of water. And we can see that these are only a couple of very specific locations inside of our district where this type of water is being measured. So I want to start actually breaking down my individual accounts to see if I can answer some questions as to which of these accounts are using these large amounts of water, and what could possibly be the reason for some of these spikes that I'm seeing. So I'm actually going to select my account, and I'm going to select my consumption, and I'm going to create a table from that. Now this will take just a moment to load. And then I'm going to order it so that I'm looking at the accounts that use the most water on the very top of this table. So we can see here that we have a couple of accounts that are using a very large amount of water. The first is this account that's using an extremely large amount of water. And we can see that it's a domestic account in 2017, which makes me remember that before I applied this filter, we actually had a domestic account in 2017 that was using an extremely large amount of water. So maybe this account is responsible for this spike in water usage that I see right here. So that kind of gives me an answer to at least one of these questions. That maybe it's this specific account I need to be focusing on to see what actually occurred during this time frame to cause this large spike in reported water consumption. At the same time, I can begin to click through the rest of these data sets, and I start to notice something very interesting, that these extremely large water uses tend to be on the periphery of my districts. So this leads me to believe that some of these may actually be bulk meters that are going out to other districts that I'm selling or sharing water with. So realistically, I've identified my top accounts and really kind of been able to segregate them from the rest of my accounts because they may have special circumstances that cause them to use that amount of water. So from here, I could really dig into those accounts specifically to try to understand what the water use is behind those. But then also I could start digging into things like my domestic accounts to find my actual domestic customers that are using the largest amount of water. So that's how we can kind of use things like Geo Analytics Server to aggregate data, then to use for future purposes inside of programs like Insights and inside of things like web applications and dashboards. Lastly, I want to take a look at some information about permits. So this is data that's not related to specifically water use or rainfall or water quality, but this is information that's related to permits for consumption of water coming from underground surfaces, underground aquifers. So if we take a look at my data set here, we're going to see that I have water use permit sites for all of South Florida. If we actually zoom in and take a look at some of this data, we're going to see that they're spread out between agricultural land and then more highly populated and fully developed areas. If I select one of these, we can see that these pumps can serve extremely large pump capacities, in this case 30,000, down to relatively small pump capacities, like 225 gallons. So I want to look at a couple of different things here. I want to see first off the density of where my pumps are, because the more pumps I have in an area, the more inspections I'll have to do on those pumps, and the more potential issues I may have to address in any given small zone. So to do that, the first thing I'm going to do is once again use my Geo Analytics tools to create a density graph of this, or a density raster of this area. I'm going to use my water use permits sites as my input. We'll just call this our pump density. I'm going to do this into a hex bin for every 2,000 feet, and I'm going to make my neighborhood size 8,000 feet. Now, I'm not interested about summarizing any data or creating this as a time series, so I would just run it as with these parameters, and that would give me a density grid that would allow me to see where the most dense areas of my pumps are. So this will take a moment to draw. And we can see that just like where all of my points are, my highest densities are in the populated areas along both coasts. We can also see here that I have a very high density of pumps in this agricultural area right in the center of my district. Now, to me, this kind of looks like this may be strawberry plantations, but that's just my guess because I know that they use a lot of water. So this shows me exactly where all of my pumps are located, but I'm also interested in that pump capacity variable that I showed before. I want to see not just where my pumps are located, but I also want to see what the maximum capacity for water being pumped out of any given area could be. So to do that, I can once again use my Geo Analytics server, and we've seen this a number of times before. I can select my water use permit as my pump layer, but only this time I can put that pump capacity as my value, and I can summarize that pump capacity. And what we see when we actually summarize that pump capacity is that unlike my density, which is spread out along the coasts, my highest levels of pump capacity actually exist inside of my agricultural areas. So we can see here on this massive agricultural area south of Lake Okeechobee that I have some pumps that have massive amounts of pump capacity in a very small area. The same holds true for some of my more agricultural areas west of Port St. Lucie as well. I also want to see not how these look just inside of hex bends, but how these actually line up with my surface water management areas. Because as we know, the more water that we pump out of the ground, especially in agricultural areas, the more water is going to be put back into the surface water system. And this water could contain, various agents like pesticides and nitrates that are run off from agricultural farming. So I can once again use my spatial aggregation to aggregate all of those water quality points or all of those well pumping points with my capacities for pumping into those surface water groups. And what we see here is that my surface water area that is just south of Lake Okeechobee has the largest possible pump capacity of all of my different areas. So even though there's only 119 pumps in this area, its pump capacity is far higher than some of these areas that have many more pumps inside of them. So this shows me essentially two different sets of data. It shows me where I have the most pumps located for things like pump inspections and pump installations and pump maintenance, but it also shows me where my highest density of actual water draw exists. So I've used Geo Analytics Server to really give me two different answers to two different questions here. So we've really spent the last half an hour here looking at how we can use Insights and Geo Analytics Server together to really help us understand our information much better. The water quality data that we created inside of Insights really shows us how we can very quickly create these extremely rich Insights pages that allow us to quickly answer questions about a wide variety of water quality results. We looked at 100 million rainfall records in a way that makes it very easy and simple to understand where rain fell and how much rain has fallen in an individual drainage basin. We've used a combination of geoanalytics and insights to first aggregate consumption data into zones and then look at that data through insights side by side with the raw data to understand what accounts may be causing spikes in water consumption in those individual zones. And then lastly, we took something like permits and used it to find out not only the density of those locations, but what the real world impact is based on their pump capacity. These are just a couple of examples of the ways that we can use tools like Geo Analytics Server and Insights to take those big data sets that we've been collecting over years and years inside of our various organizations and really start to answer questions about them. So that's all I have for demonstrations. We have about 15 minutes left, so I'm going to open it up to any questions that people may be having.
Thanks, Derek. We do have a few questions that are coming in. It seems like several of them are focused around data types. So I know you went through several different data types during your presentation. Can you spend a little more time talking about Insights and how it works with different data types, like what you showed, but also data that's coming from Oracle or SDE, CSV files, that type of a thing?
Yeah, so the data that I showed was all coming from my ArcGIS Online or Portal organization. So that's kind of the first data type that most people access in Insights, data that's actually registered or hosted inside of your organization. The next type of data that people most often use is information that's coming from the living atlas of the world. So inside of my Insights page, I have the ability to actually access that living atlas to pull in things like demographic information, county boundaries, and Census Bureau information. The third piece of data that we see people using a lot is data that's coming from CSV or Excel files. There's an option inside of Insights to actually drag and drop in these Excel files or CSV files right into Insights and immediately start working with them. And then the last one that has a very large amount of potential is the ability to access data coming from your other non-spatial relational database management systems. So this would be traditional systems like SQL Server or Oracle, but also accessing data coming from things like HANA. So we can actually connect this data up directly into Insights and then use that data to join with spatial data sets that exist inside of our portal. So you can really access data from almost any location that it would exist inside of your organization, as long as it's in your portal, the Living Atlas, a CSV or Excel file, or another relational database system.
Thanks, Derek. Just to clarify a little bit on that question, so the connection with your large data sets that might not be spatially aware, is that a live connection or is that something more like a push and pull?
So everything inside of Insights is what I like to call a kind of quasi-live connection. If we take a look at my data in Insights here, we can see that we have this refresh button. So any data set that you enter into Insights at any given time, if you want to refresh it with the newest data, you simply have to hit the refresh data set button. And then all of your cards and graphs and analysis will be updated. Now, if you were to access that data directly from Add Data, coming from one of these other databases, well, in that case, then the data would be live. So it kind of is a quasi-live. At the time you access it, it's live. But once you've completed your analysis, you simply have to hit the update button to refresh that data set with the live information.
Great, thanks. We have a couple other questions about the base deployment of ArcGIS Enterprise. Quickly went over that slide at the beginning of your presentation, and then during your demonstrations, you talked a lot about Geo Analytics Server and the big data store. How does that work, and is that all part of the enterprise deployment, or is it separate?
So when it comes to the enterprise deployment, there essentially is two pieces. The first would be these orange pieces you see here: our portal for ArcGIS, our ArcGIS server, and our relational data store. These consist of what we call that base deployment of ArcGIS Enterprise. Geo Analytics Server and the Spatial Temporal Big Data Store are additional pieces that you can federate into that base deployment. So you would first establish your base deployment of ArcGIS Server, and then if you wanted to utilize Geo Analytics Server and the Spatial Temporal Big Data Store, you would first install your Geo Analytics Server on a separate server, and you would federate that back with your enterprise deployment. You would also then install the Spatial Temporal Big Data Store as a second data store that's attached to your enterprise deployment. So both of these servers and the data store are separate entities that you would attach onto your base deployment of ArcGIS Enterprise.
Thanks, Derek. Following up on that, we have a couple attendees that are asking for more specifics about Insights in Geo Analytics Server. Do they require structure relational databases, or they can also work with non-relational databases?
So Insights kind of requires that structured of a relational database to work with if you would like to connect to one of those external databases. Geo Analytics Server can take in data from a lot of different locations, including big data stores, things like big data file shares, which is unstructured CSV data, and other locations. So Geo Analytics Server and the ST Data Store are more open to unstructured data, and Insights is if you would like to connect up to those other data sources, they have to be inside a relational database management system or something like SAP HANA.
Okay, so I know we're spending a lot of time on this, but we are getting some questions concerning this structure. Insights for ArcGIS is listed over to the left and not really part of that yellow-orange colored base deployment. So how would our attendees access Insights for ArcGIS?
Yeah, so Insights for ArcGIS is essentially an application that exists on top of your enterprise deployment. When you install Insights inside of Portal, Pieces of it are installed in each piece of your base deployment, but it's accessed just like any other application through the Insights for ArcGIS tool that essentially is a browser-based application. So both of these are available. This is available in both ArcGIS Online and Portal for ArcGIS. It is a named user license. So inside of Portal, you would have to install the Insights application onto your portal and then acquire the licenses to run Insights. Inside of ArcGIS Online, you simply need to purchase the licenses for Insights and it'll become immediately available inside of your organization.
So you can use Insights if you don't have the ArcGIS Enterprise. You can use it with your ArcGIS organization through ArcGIS
Correct.
Online. Okay.
Correct.
Great, thank you. I know that's a lot of information right there. We do have another question concerning this topic. So when you're doing this installation, are the data store and that type of what you're showing here, do they automatically get turned on when you install your enterprise?
Yeah, so both types of data stores are installations that are part of your enterprise deployment. So when you deploy and install ArcGIS Enterprise, you install ArcGIS Server, Portal for ArcGIS, and the Relational Data Store. They're all part of the whole, but each of them is installed sequentially with their own installation tools. So if you're doing this a la carte and doing these installations one at a time, you will be asked to install Server, Portal, and the Relational Data Store. If you're using something like ArcGIS Enterprise or Deployment, ArcGIS Enterprise Builder to deploy a single machine deployment, or Chef tools to deploy a multiple machine deployment, you have the ability to choose which pieces you want to install, and it'll install all of those automatically for you.
Yeah, it's a little bit of work. I took the deployment class that Esri offers, and I remember being a little surprised, but it's easier than it used to be with those deployment tools.
I would strongly recommend, if you are deploying ArcGIS Enterprise, even if you're not planning on using the Relational Data Store, to install the Relational Data Store, because there may be pieces that are released in the future that you would want to use it for, and it is more pain to go through to install it after the fact than it is to during your initial installation.
Thanks, Derek. Oh, no, we have one more question coming in. We're just about ready to wrap it up, but so we have a question about switching. If someone's using ArcGIS Online and they haven't set up the portal on premise, is it difficult to switch over? And I know we have some hybrid situations where customers are using both. What do you think about that?
Yeah, so in that instance, it really depends on the size of your ArcGIS Online deployment. If you want to completely switch over from ArcGIS Online to Portal, there are tools provided by Esri partners that can really help move some of those items over. But it really depends on your individual installation and configuration of ArcGIS Online, whether you're using wholly hosted items or you're registering those items back to ArcGIS Server. So it can range from being very simple, if you have a small amount of data that's generally registered through ArcGIS Server, to fairly complex if you have a large amount of data that's wholly hosted in ArcGIS Online and you wish to move down to Enterprise ArcGIS.
Thanks, Derek. Going back to the analysis that you performed and the results that you were getting, I have a few questions asking about how to share that. So I saw you had a couple web apps online that showed some maps that looked like they were capable of sharing internally or externally, but can we also share these results that Insights give you as far as the cards and the maps?
Yeah, so along with sharing some of the information out from Geo Analytics and applications, any of these Insights cards can be shared out. So we can actually share out a page for everyone in the public, people in our organization, or a particular member of groups. And what that's going to give you is a link to actually view that shared page, or a link to embed that page into something like an iframe for display in a story map or on a website. We can also actually share out this model as well too to the organization, so that someone can access the model that we created to do analysis on similar data or their own data set.
Thanks, Derek. I think that's about it. It looks like we've gotten to our questions. Thank you everyone for attending the webinar today. As I mentioned earlier, there is one webinar left in this webinar series. If you follow this URL on the slide, you'll be able to view the first webinar as well as register for the third one. And in about a week, this webinar today will be also posted on this page. One last announcement, if you're not aware that Esri hosts a water conference, we do have a 2-day all water conference coming up in Nashville in February of 2019. If you want more information about that, please feel free to reach out to me. Thank you. I hope you enjoyed the webinar. Have a great day.